Hello everyone. In this session, let us practice to construct deterministic finite automata that accepts regular languages with the simple conditions given. We know that DFA will make single transition on input symbol. So here it is given that the DFA has to accept language of alphabets A, B with strings having exactly two A's, which means the words in the language can have only two A's, but the restriction about B's is not mentioned, which means any number of B's and it can appear anywhere in the string. So let us construct the mathematical model DFA with 5 tuples, Q representing the set of states, sigma representing the input symbols in this problem A and B, delta the transition rules, Q naught the initial state, and F as the final state. So now the words that are accepted by this language would be two A's. So meaning only the first word let us consider as two A's. But it can have even B's. This B, if it appears in the beginning, it can be as BAA. If it appears at the end, it can be as AAB. And it is not mentioned that these A's should be consecutive, which means in between these two A's, we can have a B. And the number of B's also is not restricted. It can be 2 B's in the beginning, or it can be 3 B's at the end, or their combination AA, B, BB, or in between B, A, BB, A, BB, anyway. So which means the regular expression will be, we should ensure that two A's are there, and in the beginning there can be any number of B's, at the end there can be any number of B's, and in between there can be any number of B's. So B star A, B star A, B star is the regular expression for this regular language. Now let us construct the automata correspondingly. So first always let us draw the DFA for the basic unit of this language, that is 2 A's. So it can start with Q naught state. On reading A, it can go to another state Q1, and then on reading second A, it can go to the final state Q2. So this will accept simply 2 A's. Now to accept remaining words, we should see the possibility at every state of getting the input symbol. If B's appear in the beginning, it is mentioned that there can be any number. So we need not even make transition. Any number of B's can be there in the Q naught state itself. Similarly, in between also any number of B's can be there, and at the end also any number of B's can be there. Now we should ensure that at every state the possibility of all the input symbols are done. So on B it goes to Q naught, on A it goes to Q1. Similarly in Q1, on A it goes to Q2, on B it goes to Q1. On Q2, now if it reads a A, it should not be accepted. Therefore, if it reads a A, let us move to the state Q3. But Q2 is only the final state. This Q3 should not have any possibility of reaching Q2, which means on reading A and B in this Q3, it should remain in Q3 itself. So any word that is having more than 2 A's will not be accepted. So this is the DFA corresponding to this language. So Q naught on A will go to Q1. Similarly, Q1 on A will go to Q2, and Q2 is the final state represented by star. But when it reads a B, it will be there in Q naught itself. Similarly, in Q1, if it reads a B, it is in Q1 itself to ensure any number of B's to be read. But in Q2, if it reads a A, it should not be accepted. Therefore, it goes to the Q3 state, which we call it as dead state or sync state. Similarly, Q3 on reading A or B, it should be in Q3 itself. Now, let's see the next condition. Construct a DFA to accept the languages of alphabets A, B with strings having at most 2 A's. At most means maximum 2 A's, which means there need not be a A itself, or a single A, or 2 A's. And about B's, they can appear anywhere, any number of times. This is what is given in the question. Therefore, a similar mathematical model can be constructed now. So the possible words could be simply no A or B, or simply a B can come, or any number of B's can come. And then we can have single A. For this A, any number of B's can be in the beginning and after that A. Similarly, there can be simply 2 A's, or as we saw in the previous example, any number of B's can be in the beginning, then in between, and at the end after this second A. So these are the possible words that can be present in this language. Therefore, the regular expression is, as they have given at most maximum, there need not be a symbol read itself. So which means epsilon is accepted, null symbol is accepted, or single A is accepted with any number of B's. So A can be preceded by B star and followed by B star. Similarly, the third possibility is 2 A's, in which we can have any number of B's in the beginning, in between, and at the end. So these are the possibilities of words that are accepted. Regular expression is given like this. Therefore, now we can construct the automata as from Q naught. Before even we could read any symbol, with no symbol, it is accepting. Therefore, Q naught is also a final state. Now, any number of B's can be accepted in this place. Now, when we read a single A, even one A is accepted. Therefore, Q1 also will become a final state. Now, even in Q1, we can accept any number of B's. The second A is also accepted. So, 2 A's, maximum up to 2 A's it can accept. Therefore, Q2 also is final state. Here again, it can accept any number of B's. But when we read a third A, then it should not be accepted, and after that any character should not be accepted. So A or B should not be accepted. Therefore, Q0 on A will go to Q1. Similarly, Q1 on A will go to Q2. But Q0, when it reads a B, any number of B's are accepted. Therefore, it can be in the same state. Q1 similarly, when it reads a B, any number of B's are accepted. Therefore, it can be in Q1. Q2, when it reads a B, any number of B's are accepted. Therefore, it can be in Q2. But Q2, when it reads a A, it is the third A, which should not be accepted. Therefore, the transition is to Q3. In Q3, no character should be accepted. Therefore, it is in Q3 itself. But we should note that in this problem, there are 3 final states. So, Q0, Q1, Q2, all the 3 are marked with star symbol in the transition table. Now, let us see another example with at least 2 A's. So now, when they give us at least 2 A's, it is minimum 2 A's. There can be more than 2 A's in the language. Therefore, for minimum 2 A's, as we did for exactly 2 A's, we have to draw the diagram. On single A, second A. So it should accept for 2A's, and after that, from third A onwards, it can accept. Therefore, instead of going to the sync state, it can be in the final state itself. This is the only difference in this problem. That is, on Q naught, it can read A and go to Q1, and in Q1 it can read a and go to Q2. So at least two A's are read. Now in Q2, if it reads another A, third A or fourth A or any number of A's and B's, it can be accepted. As in the previous case, any number of B's are accepted in the beginning or in between, because no restriction is mentioned about B's. So this is the DFA to accept languages that has at least two A's in its strings. Thank you.